All right, we're going over our Unit 4 review, talking about congruent triangles. So let's go ahead. Question 1. In the figure below, we have segment AB is parallel to DC. Whenever you read these, mark it right away. So AB, this one, is parallel to DC. There's our parallel symbol. AD is parallel to BC. All right, so we got some parallel lines going on here. All right, which statement best describes why ABD is congruent to CDB? ADB, so this triangle is congruent to the other one. All right, well, let's go ahead and just, I like extending these parallel lines. It lets me visually see it a little bit better. And we got this one right here also. All right, and this one over here. Then we have this transversal. I'll go ahead and just darken that in right through there. All right. So let's see. We got some alternating interiors here. So this angle and this angle are the same. Okay. And on the other set, so that would be, I was talking about this one right here. Looking at that parallel and that parallel, cut by the transversal, this one has to match with that one right there. Okay, let me go ahead and change colors. All right, and then if I look at the other set, so if I look at this parallel and this parallel and that same transversal, okay, then that same alternating interior. So then that means this one angle has to match this angle here. Okay. And let's see if we have anything else. Let's see. So, all right. I think that's about it. And notice we're also sharing that side. That's a real common one. So that's our reflected reflection property of reflection. It's sharing that side right there. All right. So what does that mean? Well, we got, let's go ahead and go through our congruency. Side, angle, side, 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 angle, side, angle, 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 side, hypotenuse, leg. All right. So we got an angle 1, we got a side, and we got an angle 2. So ASA on this one. So we got red angle, purple side, purple angle. Can you do that same pattern going through it? Red angle, purple side, purple angle. Yes. So angle, side, angle. So by angle, side, angle, that's how we know they're congruent. Which statement best explains why these are congruent? Well, let's see. All the letters match. Okay, so we're okay there. And there it is, angle, side, angle, because alternate interior angles, that's right, alternate interior angles are congruent, and we have that shared side. So that's definitely it. All right, next one. Oh, I like how it erased it for me. Good. All right, a student claims that two triangles are congruent. Select each process that the student can take to justify the claim. Congruent triangles. I'm just going to get it out of the way. Side, angle, side, 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 angle, side, angle, 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 side, hypotenuse, leg. And that was my mistake right there. All right. Student, show that the corresponding sides of the two triangles are congruent. Corresponding sides. Side, side, side. That one works. Show that the corresponding sides of the two triangles are proportional. That's similar. Nope. Show that there exists a sequence of rigid motions that carries one triangle onto the other. Yes, that's the definition of congruence. Rigid motions matches it on top of it. Yep. Show that two corresponding angles and the included side, that means it's in the middle. Two corresponding angles and the side is included in the middle of the two triangles. Is ASA one? Yep. And show that there is a sequence of rigid motions and dilations that carries. No, that's your similar again. So our answer, A, C, D. All right. Use the diagram and the information below to answer the question. Given that AX is perpendicular to BC. All right, so that means we got this as a right angle also, or 90 degrees. Perpendicular on both sides of there. XB is congruent to XC, and they gave it the tick mark, check. And I went ahead and I marked that off. And prove that these triangles are the same. Well, there's that side of reflection again. So that matches. I'll give it 2 tick marks. So by side, angle, side. They match. Side, angle, side. All right. Which statement is not part of the proof that shows, okay, which statement's not parts? AXB and AXB and AXC are right angles because they're perpendicular lines. Nope, we need that one. XB, so we're looking for which one's not it. So that one's okay. XB is congruent to XC. XB is congruent because it's given. Yep. And XC is congruent to AX is congruent to AX because of the reflexive property. I think I said reflection property, reflexive. Yep. And AB triangle AXB is congruent AXC because of side, side. No, we're not using side, side, side. We're using side, angle, side. So the one that's not it is D. And triangle XY, I'll just go ahead and the triangle's reflector constant. All right, let's see. All right, well, you could draw this if you're not sure, draw it. But I think we have enough information for what we have here. Which is true? We're looking for the true one. All right. So the mappings have to match. And we are talking about reflected across. So that means it's congruent or the same. So it's congruent or the same. So that means these primes, x prime, y prime, has to match xy. So xy is 10. Let's just go through each one. xz is 10. X prime, z prime is 10. No, x prime, z prime is the same as xz, which is 14. So that should be 14. Y prime, z prime is 15. Y prime, z, yz is 15. So yep, that one's true. They have to match, and that one does. Let's just make sure the other ones are not the same. And x prime, y prime should be the same as xy, 10. Nope, not 14. It should be 10. The perimeter of XYZ is 39. So if you add up all the sides, so 10 plus 15 plus 14, I get 39 inches, the perimeter, which is true. I get this one also. Okay. Yes, so it's not just one answer. They didn't say anything, pick the right one, so it looks like we have multiple answers on this. Careful, but those do link together. You're just double checking 10, 25, 39, yep. All right, given that angle X and angle D are the same, DE is congruent to XW. Was the third congruence needed to prove that? Ooh, okay. So this is the one where you better draw it. So I'm just going to do XYZ. No, XWY is congruent to, and make sure you have that same order. X matches with D. So it has to be bottom left on mine. W matches E. So it has to be right there. And then Y, the last letter, matches C, the last letter. So it has to be right there. All right. If you want, you can just mark these. But given that X and angle D are the same. Angle X and angle D are the same. Okay, those match. Got it. And DE, this one right here, is the same as XW, Okay. All right. So what's the third congruence needed to prove that these are true? All right. Well, let's see. Get them out if you don't know. Side, angle, side, 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 angle, side, angle, 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 side, hypotenuse, leg. All right. We don't have to worry about hypotenuse, leg. Everything here are angles, so I don't have to worry about the sides. I only have one side, so I don't have two sides. I don't have to worry about that one. So these are the only two it can be. I'm going to go ahead and switch colors to make it a little easier to see. All right. So what else would I need? Well, for angle, side, angle, the side has to be in between. So for angle, side, angle, I need angle W to match angle E. Those two for angle, side, angle would have to be the same. So angle W would match angle E, congruent. That would make them the same. That would give us ASA. So angle W is matching angle E. Angle W is matching angle E. There it is. And if we did AAS, angle side, let me switch my colors again. Let's do like a light blue. So that would be if we had angle, I'll do it over here. If angle Y, so that would be that angle, was congruent to, matched angle C. So if that angle matched, I would have angle, side, angle, side. So angle Y would match angle C. Angle Y would match angle C. What is the third congruence needed to prove these? Angle, side, angle. Okay. So notice there's only one click that they're giving. That's nice. So which one was angle, side, angle? Angle, side, angle was W and E match. W and E match. Good. And it's always good, like I showed you, just reread the question before you move on, just to make sure you got it right. I'm treating this like if I were taking the test. All right. Question 6. Let's see. Now let me zoom out a little bit. Color going. All right. Given that line segment WZ bisects line segment XY. So WZ bisected XY. And XY bisects line segment WZ. Well, if let's look at the first one. If WZ bisects XY, it cuts it in half. So WZ cut in half the XY. So that means this one and this one have to match. I'm just going to let my colors link together. And then for this one, XY bisects or cut in half the WZ. So that means this one has to match this one. Bisect means it cuts in half. Whatever it cut in half, those have to match. All right. So, and that would be a definition of bisect. I see it's trying to prove it. Triangles WAX and ZAY are congruent. Try to prove that. So that's your goal, so that these are congruent. Well, let's just go ahead and look and kind of finish it off here. So I'll do green this time. Notice that we have that bow tie. There's the bow tie. Every time you see that bow tie, be ready to match vertical angles. Those angles have to match. So that would be side, angle, side match. And you have that same match. So red, green, purple in order. So side, angle, side is how you prove that. And that's everything that we need right there. All right, so let's just go through their definition and we'll fill it out. All right. Segment WZ bisects XY, that's given. Segments XA and YA, segments XA and YA match. That's because that's the definition. When segments are bisected, the resulting segments are congruent. Yes, by the definition, right? Segments XY bisect WZ, that's given. So what's missing is those purples, that WA is the same as AZ. WA is the same as AZ. Okay, and they're the same. WX are congruent, vertical angles, yep, and then are congruent because they're two sides and the included angle, but that's just side, angle, side. Okay, so which should be in statement 4 to complete the proof? Let's just make sure there's nothing else. So notice if I multi-click, it gives me options. So it's it has to be just that one. But let's look. Angles XWA, XWA, and YZA are congruent. Nope, they never gave us anything about that. WX and YZ, WX, nope. And YZ, they never gave us anything about that. And angles WXA, WXA, and ZYA are, nope, they never gave us anything about those. So it's definitely that one. Good. Let me just a second. WA and AZ, WA and AZ, yep. All right, find the value of the variable that results in congruent triangles. Find the value of the variable that results in congruent triangles. Okay, so 6950 blank. All right, so that means we need to find this. What does all of this equal for that angle right there? All right, so we got the 50 and 69. We got the 50 and 69. So we just need this last angle. And we got the side. So by side, they're congruent. We just need that last angle. So 50 plus 69 plus angle H is equal to 180. I'm just going to switch colors. I like looking at it more visual. So 50 and 69 is 119 plus angle H equals 180. So we're just, all the angles of a triangle have to add up to 180. Minus 119, angle H is equal to 61. All right, so angle H is also said that it's 2x plus 5. So if this is 61, then 2x plus 5 has to equal 61. Minus 5, 2x equals 56. Divide by 2, and I get x equals, what's that, 25 plus 3, 28. There it is right there. All right, I just like confirming. So 2 times 28 is 56 plus 5, 61. Check, 28. That's our x. They want the value of the variable that results. Yes. All right. Which theorem or postulate can be used to prove that this is the same? Okay. Well, we got a shared side. So that matches. That's that reflexive, not reflection, reflexive property. Which theorem or postulate can be used to prove this? All right. So we got this shared side. AA is definitely not it. ASA or SAS, or there's not enough. Oh, I didn't even see that. It's kind of tiny right there. It's given that the AB is parallel to DC. So AB is parallel to DC. That means we have some matching angles with alternate interior. So alternate interior means this one and this one match. Do they give us anything else? It doesn't look like it. So we would need either this side. Nope, that would give us SSA. We would need this side to match with this side, which it doesn't. We don't know. Or, so that would be side angle side if it was, but it's not. Or angle side angle. That would be this angle. But notice right here, it would have to go all the way over there, all the way over there. So we don't have that either. So there's not enough on this one. And I just like checking now if we can have multiple answers. All right. Let's see. Oh, I feel like this is pretty good for now. Let's go ahead and, I don't know. I'll see if I can't push it through. Let's go through it. AB is parallel to DC. AB is parallel to DC. And we got that shared side right there. Angle A is the same as angle C. Angle A is the same as angle C. AB is, I forgot to mark it, it's parallel to DC. All right. This looks like that alternate interior again. So by alternate interior, this one has to match with this one right here. So that's angle, angle, side. Purple angle, red angle, side that matches. So ASA. Which theorem can be, or postulate ASA. Don't pick that one. That's definitely wrong. Don't pick that one. That's definitely wrong. Angle, angle, side, that could be it. So those were definitely not even possibilities. So A or D is, you're not understanding what to do here. Or you haven't practiced these. Remember this one, it could be said as ASS, which is not one of them. And this one is the same as SAA, but it's not. That's the AAS that we showed. SAA, is that it? Ooh, Sanders. Careful, let me just double check here. Well, I know it's not those two. Before I move on, I got angle, angle side. Oh, gee, almost took you down the wrong trail. Notice angle, angle, side. The side's not in between. I just wrote it wrong. So it's angle here. Then I'd go to this line. So that purple angle, that red angle, and then that side. So it's angle, angle, side. Eesh, that was close. Almost missed that one. All right, continuing on. Got 5 more to go. 6 counting this one. Or 10, 11, 12, 13, 14, 15. Yeah, 6 counting this one. D, E, F, and triangle are 2 triangles. It's that DE is the same as MN, and EF is the same thing as NO, which of the following could be sufficient. All right, so definitely draw it. And we got, so D, E, F. No need to change the order. M, N, O, according to the mapping. The bell is going to go off in just a moment. Sorry about that. And it tells us that DE is the same as MN. EF is the same thing as NO. Okay. Which of the following would be are congruent? This would be, if even to have a chance at it, would be like parallel idea. So that's our similar idea on that one. So I'm not even worried about that one. DE is the same. DE is the same as DF. Nope. That's sticking in the same triangle. Angle D is the same as angle M. Angle D is the same as angle M. ASS. Nope. That's our ass right here. That's not one of them. And then angle E. Angle E is the same as angle N. So by side, angle, side, we have the match. So yes, it is that one. All right, 11. Which graphs below show that ABC is congruent to A prime, B prime, C prime by reflection? By reflection. Oh, gee. So we're going into reflections here. Well, no, it's not that. That's a dilation. This one would be a reflection over here, and you can tell that it just got moved. That would be a translation, so it's not that. Reflection, this is a rotation. Notice it got rotated or moved, so not that one. And the reflection, it looks like there's some sort of reflection going on here. Usually it's this kind of reflection. So let's just go ahead and see. I can count it out. If this is the y equals x line, doesn't hurt to check. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And I want to make sure I go straight through this. There. So my y equals x line was off. So y equals x would have been that. Okay, that's a little bit better. So how many was it? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it has to be 9 this way. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's a reflection over the y equals x line. That one's a little bit tough. So we'd have to do that old reflection trick. All right, triangles PQR and STU are congruent. Select each statement that is true for all triangles PQR and STU. So let's just go through it. Corresponding sides of two triangles are congruent. That's true. All the sides have to be the same for congruent triangles. Corresponding angles of the two triangles are congruent. Yes, all the angles have to match that are matching. There is a set of rigid motions that takes one triangle into the other. Yes. Everything's true on this one. Yep, so the motions, that's the definition. The angles have to match, and that's true about it. So this is not enough if you're going from there, but if they're congruent, are congruent, then this is true. So this is like these two right here is your corresponding parts of congruent triangles are congruent. And this is your definition of congruence. Given two triangles, if two pairs of corresponding sides and one pair of corresponding angles are congruent, then the triangles are congruent by side, angle, side. Which of the following best describes Angie's statement? So if two pairs of corresponding sides, so I don't know. Let's just go ahead and look at. So we got two pairs of corresponding sides. So we got this one, this one, this one, this one. That's two pairs of corresponding sides. Check. And one pair of corresponding angles are congruent by side, angle, side. All right. So one pair of corresponding angles are congruent. That means for this to be true, the angle has to be the included angle, INCLUDED. If this is the angle they're talking about, that would be angle, side, side. That's your ass again. So for this to be true, it has to be this angle. That's the one that has to be true for the two sides. If sides are matching, it Has to be the angle between them that matches. Which of the following options best describes Angie's statement? Okay, let's see. Angie is correct since side angle, side. No, that angle could be off. Angie is incorrect. It's not congruent. Oh, nope, that side angle side's my first one in the song. Angie is correct since any two pairs of congruent sides and any pair of congruent angles will. No, it's not any of them. It has to be the included one. Angie is incorrect since triangles with two pairs of congruent sides do not necessarily. It does not necessarily meet it. That's right. It has to be the included for it to meet it. So if it's the other two, it doesn't. A student claims that two triangles are congruent. Select each process that the student can take to justify the claim. All right, so if they're congruent, let's see. Show that the corresponding sides and angles of the two triangles are congruent. Yes, you don't need the angles, but if you show the corresponding sides are congruent, that's enough. So that's just extra information, but this would be enough. Show that there exists a sequence of rigid motions that carries, yep, that's true. So no dilations, but you match one on top of the other. Show that there's a sequence of rigid motions and dilations, no dilations for the congruence. All right. Yay, last one. I think. Hope. All right, yes, last one, finally. All right, Helga knows that the corresponding angles of two triangles are congruent. So she claims that so by angle, 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 which is, that's similar, not congruent. So that's the similar idea. Not congruent. This is not one for congruence. She claims that the two triangles must be congruent. No way. Which best describes Helga's claim? Helga is correct. Nope. But let's read it. Since two triangles have corresponding angles. Nope. That's not a true statement. That would just be similar. Helga is incorrect since the two triangles must also have congruent corresponding sides. That would be true. You need those corresponding sides. That'd be side, side, side. Or if the angles kind of play a part in that, that would work. Helga is correct since three angles determine one unique triangle. No, three angles do not determine one unique triangle. And Helga is incorrect since only similar triangles, but not congruent triangles, have congruent corresponding angles. That is true. It's only let me click on one. I got both of those. All right. Let's decide which it is and see how we did. All right. Well, don't save my answer yet. All right. Helga is incorrect since only similar triangles, but not congruent triangles, have congruent corresponding angles. Only similar triangles, not congruent triangles. Well, no, yeah, so maybe I just read that too fast. Only similar triangles, not congruent triangles, have corresponding congruent angles. No, not only similar. Both of these, both of these are, you would have congruent triangles if they have corresponding, congruent triangles can also have corresponding angles. They have to. So if the triangles are the same, their angles and sides are the same, so that's not it. So that's not a true statement, but that's real tricky how they worded it. So it has to be this one. Since the two triangles must also have congruent corresponding sides to be congruent. Okay, let's see how Sanders did. And does it tell me? How did I do? It didn't even tell me. Oh, well. But yes, I'm pretty sure I got them right.